All right, so as we're looking at section 3, multiplying binomials. Once again, binomial, how many terms? 2. So we're multiplying 2 terms times 2 terms. And I'm going to show you 2 methods today. The first one explains the overall process. Good morning, Justin. The second method is going to be more of our typical process as we look through this. But I've kind of written it out here. X plus 6 times 2x minus 4. And the idea is this x needs to multiply by the 2x and the minus 4. Then the plus 6 needs to multiply by the 2x and the minus 4. And so what I did is I broke it out kind of into idea of distributing. X times both of the ones at the back and plus 6 times both of the ones at the back. So as we're looking at these, Zach and Noah, help me with the first one here. X times 2x is what? 2x squared. Okay, so there's our first one. And Noah, can you do the other one? X times negative 4? Negative 4x. So there's the first half. Then we do the second one. Let's go over Tara and Jalan. 6 times 2x minus 4. Tell me what the 6 times the 2x is. 12x. And then Jalan, the 6 times the negative 4? Negative 24. Now most times when we're multiplying binomials, you are going to see the middle 2 terms are going to be very similar. In this case, minus 4x and plus 12x. What do those combine to? Positive 8x or negative 8x? Positive. So, those are there. Our 2x squared is in the front, and our minus 24 is at the back. My question is that in standard form? It is. What is standard form? Just a reminder. Drew?
Decreasing numbers.
Okay, the degrees are decreasing. Okay, so this is standard form. Now look over on the board there. The highest degree on this is a 2. Look on the board. What is that called? Okay, so this is a quadratic. A quadratic what? A quadratic trinomial. Now that's not going to be part of your homework, but I want to continue to emphasize that so we're comfortable naming a polynomial. So, all right. Let's look at our second one. Hey, Jalan. Thanks. A binomial times a trinomial. So, how many multiplications am I going to end up doing total? Here I did 1, 2, 3, 4. How many am I going to do over here? 3 times these 3, and then the 8 times these 3. So how many total? 6 total kind of incidences. So I'm going to write the 3x first times 2x squared plus 3x times 9x plus 3x times 12. Uh-oh, I'm not planning ahead here. Plus 8 times 2x squared plus 8 times 9x plus 8 times 12. It's a long problem. Because you've got all these different multiplications you've got to do, first you multiply the 3x times all 3, then you multiply the 8 by all 3. So let's walk these through. All right, Haley and Kyle. 3x times 2x squared. It is 6x cubed. All right, so that one's done. Going back at table. Brett and Hannah. 3x times 9x. 27x squared. Good. All right, going back at table. Luke and John. 3x times 12. 36x. Going back another table. Ryan and Sam. 8 times 2x squared. I heard 16x squared. All right, going over a table. Luke, 8 times 9x.
8 times 9 is 82.
72. But
72.
good man. 72x. All right, can anyone do this in their head? How much? 96. Good. Wow, that's a lot of terms. So let's see, did we end up with 6 of them? 1, 2, 3, 4, 5. Okay, we ended up with 6. Now, Would you say we're done? Luke, you're saying no. Why?
Because you have a bunch of x's that we need to do.
All right, so let's try to combine things that are alike. Any cubes other than 6x cubed? So I'm going to write that one down. Now let's look for squares. There's a square. There's a square. What's 27 plus 16? Well, 27 plus 10 is 37, plus 6 more, 43. All right, now just single x's. 36 and 72. Jelon? 1. Really close. 108. Yeah. 108 and an x. And then the 96. There we go. All right, what kind of polynomial is this? Highest degree is a 3. If we look at our sideline, it's a cubic polynomial. No special name. Cubic polynomial. So that is using the idea of distributing. Multiply each part in the first parentheses times every single one in the back. So as you're working on some of your problems today, obviously copying on the problem is going to be extremely key. In this step, showing all that work will keep you from making errors. So hopefully that will be pretty straightforward. But realize you're going to need to make sure you start on the far left and write neatly all the way across so you don't end up with kind of the curl like we did here. Now, I want to show you more of the common, typical method, because most times we're not doing larger problems like this. Most times we're going to do problems that are a binomial times a binomial. And that's a process that we have called FOIL. Have you ever, you know what an acrostic is? The word acrostic? It's when a word represents, each letter represents an action. So an acrostic is the word FOIL. And it stands for first, outer, inner, last. And let me explain what those ideas are. When I say the first two terms, this is the first term and that's the first term of the binomial. When I say the outers, I mean the one on the outside, the x and the -4. Those are the outers. When I say the inners, I mean the two ones on the inside of the parentheses. And then when I say last, I mean the last one of the first group and the last one of the second group. So when we say first, outside, inside, last, that just helps us to remember what am I multiplying by what to get all the different sequences together. And what I love, if you draw the picture of it, you end up having kind of this picture of these two parentheses, and we'll draw it on the board here. There's first, there's outer, there's inner, there's last.
Looks like Harry Carey.
Harry Carey, or it's the Lemonhead Man. You ever see Lemonheads?
Yeah.
That's the Lemonhead Man. So there we go. Anyway, that's kind of a little remembering, and if you draw your lines and make sure you end up with that Lemonhead Man, you know you got all the right multiplications. So here we go. I'm going to trace over them as we draw them. So first, trace over that line and help me out. What is x times 2x? 2x squared. So there's first. Outer, trace over the outer one. What's x times -4? -4x. Now inner, what's x times 2x? Sorry, what did I say? 6 times 2x. Thank you, Jalon. 12x. And then last, 6 times -4. -24. All right, we look for our like terms, and we write our answer. 2x squared plus 8x minus 24. We're going to start using the word FOIL almost as a verb. I'm going to say FOIL it. And that means multiply the two binomials together, first, outside, inside, last. So let's try 4. Foiling here. Draw it first. First times first is 3x times 3x is how much? 9x squared. Leave some space to draw your lines. Outside, somebody else, Now you got to give me a sign. Plus or minus?
Plus.
Plus. Inside. Good, thanks for giving me the sign. And last. Minus 80, good. Look at our middle two. Are they like terms? Okay, so who can give me my answer all the way out? That's 6x in the middle. So I tack the 9x squared on the front and the minus 80 on the back. And we're done. What kind of trinomial is this? Quadratic. Quadratic. What kind of trinomial is this? Quadratic. Most of them are going to end up being quadratics. All right? All right, flip over. Who feels comfortable with the FOIL? Luke and Jalon and Brett. All right, I'm going to come at you guys. Brett, take it away.
Well, you do the first, so x
And that is?
8x.
Guys, leave like an extra line underneath your problem to draw your smiley faces on the homework tonight. Keep going, Brett.
You do the hours, so x times 9.
Okay. Do me a favor, always say like plus 9x or minus 9x, just so I know what to write.
Then you do inner, so
Negative 6 times 8x, okay, is?
minus,
Help them out, somebody. Minus 48x, good. And then finally,
and then you do the last, so negative 6
negative 6 times
times 9,
9,
minus 50.
minus 54. All right, Jalon, you're our combiner. That's a plus, by the way. Sorry, I kind of made that hard to see. Good. Negative 39x. There we go. Good teamwork. So FOIL. First, outside, inside, left. Make sense? All right. Try number 6 on your own. Work with your partner, and I'll do it slowly up here at the front. So if you get stuck, you can look up. We did? Was it the same one? Maybe that's why it's good for you to practice it without looking back. Methods to my madness. Were you successful? All right, so that's called foiling, or multiplying a binomial times a binomial. Now, down here I kind of have an application that we're going to have to use this idea. It says find the area of the non-shaded region in terms of x. So I want the area, kind of all this part that I'm putting lines through right now. How do I find the area of that bluish shaded section? Give me some thoughts. Luke, what do you think?
You gotta get the area of the whole thing and then subtract the area of the shaded part.
Okay. So how do I get the area of the whole thing? How do you get the area of a rectangle? John? Length times width. Okay, so we got to get the area of the whole thing. So here's the whole. 5x plus 4 is the height. 2x plus 3 is the width. So let's multiply that. Yeah, we're going to have to FOIL it. Luke, you said you were good at this, so go ahead and walk me through it, Luke.
So you do 5x times 2x and it's 10x squared.
Good.
And you do 4 times 3.
Outside. Think outside.
Oh yeah, so 5x times 3.
Okay, so there's outside.
15x.
All right, 15x. Now inside. Just what you said, the 4 times the 2x.
Okay, and then you get 6 or 8x.
8x, good catch.
And then you do,
The other eyebrow,
what? No, do 4 times 3.
which is 12. All right, so our area of the whole, it's okay, it gets better with time. 23x and 12. So there's my whole, right? So I'm halfway there. Now, we have to find the area of the shaded. Someone tell me, what do I multiply to get the area of the shaded? I can't hear you. Okay, so what's the length and what's the width? X times 3x plus 5. Mr. Dutton, could you multiply that for me?
That's 8x squared.
Okay, plus 5x. All right, now, so there's my shaded. There's my whole. Now, Luke, I'm going to come back to you. Now we found the areas of the shaded and the whole. And now what did you say we need to do?
Subtract.
Subtract what from what?
Subtract the shaded from the whole.
Okay, so I need to write down here my whole, 10x squared plus 23x plus 12. Put big parentheses around that, right? And then a minus sign, and then big parentheses, 3x squared plus 5x, right? Is that what you said to do?
Yeah.
What do you guys remember about subtracting a parentheses? This is a couple days ago. Ryan? We will get the like terms together, but there was something special with this minus sign here. There was an implication. Drew?
Put a 1.
Okay, we put a 1 there. Do I do anything to the front half? Or just recopy that? Okay, so then 3x becomes negative 3x squared. And what about the positive 5x? That becomes negative as well. Now, Ryan, or your step, are like terms. Here's 10x squared, negative 3x squared. Ryan, what does that give us? 10x squared minus 3x squared. 7x squared. All right? 23x, negative 5x. Somebody else? Ryan? 18x plus 12. So, the area of the non-shaded region is this units squared. Boom. That many units squared. I don't know what it is because I don't know the value of x, but that's how you're going to go about doing it. Couple ideas. We had to remember how to FOIL, and then also how to distribute that negative. If you don't change this 5x to a negative, it's going to cause a big problem. So make sure we're okay there. All right, down at the bottom, we already remembered what 15 squared was. 15 squared was 225. Now, without any calculation, what does 16 squared end with? 6. This is how I remember 16 squared. What does 15 squared end with? The last 2 digits are 25. Guess what 16 squared is? 256. It's just little tricks that I've learned to help me remember those numbers. So 16 squared is, everybody? 256. Here we go. All right, so let's look at page 19. Draw a line under 16 squared. Get your pencils at the ready on 16. And you're going to go up. Who's won so far? Okay, you guys cannot stand up. All right, so if you haven't stood up yet in the first, second, and third place, you are in the running. All right, on your mark, get set, go.